All right, this lesson is 7-7, day 1, transforming exponential and logarithmic functions. So in this chart, it shows you the exponential functions transformed. So the first thing can happen is you can have vertical translations moving the graph up or down. So if it's a plus k, it's going to move it up. If it's a minus k, it's going to move it down. So plus k moves it up, minus k moves it down. The next transformation is horizontal translation. Those are moving it left or right. So those happen inside the function. And if it's a minus 2, so notice it's up in the power, it's going to move it to the right. So minus h moves it to the right, and then a plus h will move it to the left. The next thing that can happen is vertical stretches and compressions. These happen in front of the exponential. So notice that here is my exponential multiplier of 6, so it's going to stretch it. And that is because our a is greater than 1. If our a is a fraction, it's going to compress it. So again, if our a is a fraction, a number greater than 0 but less than 1, it'll compress it. Our last transformation type is reflections. We have 2 types. If the negative is in front of the function, it's going to reflect it across the x-axis. So negative f of x. If the negative is inside the function, so up in the exponent, it's going to reflect across the x-axis, so f of negative x. When we think about graphing exponential and logarithmic functions, we do have asymptotes that help guide the curve. When we have an exponential function, there is a horizontal asymptote at y equals some number. If it's a logarithm, we have a vertical asymptote at x equals some number. And how we find y-intercepts is we let x equal 0 and solve for y. So here's an example. Given this function, and it's an exponential, base 2 raised to the power of x minus 2. So what we do first is we graph the parent function. So the parent function is 2 to the x power. So we evaluate it for some nice x domain values. So 2 raised to the negative 1, 2 raised to the 0, 2 raised to the first, 2 raised to the second. And we get 1/2, 1, 2, and 4. Then what we would do is we graph those ordered pairs. So negative 1, up 1/2, over 0, up 1, over 1, up 2, over 2, up 4. So this is what the curve will look like as the parent. I'm just denoting a point over 0 up 1, and then over 1 up 2, just giving you a couple points. So that's the parent. Now the parent does have a asymptote. It has a horizontal asymptote at y equals 0. Now we're going to go ahead and identify x minus 2. What does x minus 2 do to the red function? So notice that it is up in the exponent, So if I highlight this, it's up in the exponent. So it's going to move that graph 2 units to the right because it's a -2. So the transformation is right 2. So what we can do is we can just take those ordered pairs and move them all to the right 2 units. So this ordered pair here would be over 2 up 1, and this point here would be over 3 up 2. Now we have the child, the g of x, in the purple. Our horizontal asymptote did not move at all, so it's in the same position. To find the y-intercept, we evaluate the function, and we're doing the g of x function. So g of 0 is 2 raised to the 0 minus 2, and then we have to use our calculator, and we get 1/4. So the y-intercept is over 0 up 1/4, right there. Over 0 up 1/4. The domain, you can substitute any number in to the g of x function. And then the range of values, everything above that green line, y greater than 0.